next lesson is continue on with more polyatomic ions and some that vary from the list that you saw in the last lesson. But first, you might want to do a quick warm-up to check to see how your learning has been so far with the first few lessons on nomenclature. So, we're going to go through a couple of questions. So, first there are 4. See if you can name any of the following compounds here. So write them down on your paper, pause the video, and see if you can answer them. Hopefully you've had a chance now, if you're unpausing, to write the names of these 4 down. Next, let's take a look at writing some formulas, and then we'll take a look at the answers for everything together. So same thing, write these names down, pause the video, and see if you can write the correct formulas. Again, remember, you can always have your periodic table and your ion list to get the answers for these questions. Okay, we're back. Now let's take a look at the answers. Please make sure you try doing these warm-up questions. It'll help you sort out a few things before we move on and also refresh your memory on what you've learned. Okay, so here are some answers for the first 4. We've got a metal and a polyatomic ion. So the metal name doesn't change. It's just calcium, and the name of the polyatomic ion is cyanide. Here we have 2 nonmetals, so this is a covalent compound, and only 2 elements, so we know it's binary. And with binary covalent compounds, we use those prefixes. So the 2 here with the phosphorus means we have diphosphorus for the first part of the name, and the 5 here means we have 5 oxygens, so we say pentoxide. Next, we go on to nickel. We've got nickel and chlorine, so metal and nonmetal. When I look at my metal, I notice it has more than 1 charge. It's a multivalent element. So I have to decide what the charge is, and I have to put it in. Now here I chose to use the Roman numerals, but you could have also used your classical ending here because it didn't specify which naming system to use. So if you did that one for nickel, then that would be okay. When you combine it all together, you get nickel, Ni, Cl3 is for chloride, and the 3 comes from the charge of nickel. Lastly, at the bottom here, we've got Ba and a big polyatomic ion here. So this is a metal, and this is a polyatomic ion. So metal, again, doesn't change its name, you just write it down. But have a look on your list for that nonmetal, it's acetate, and you just have to write the name there. Let's check the formulas that you wrote down for the last 4 for this practice example. Sodium hydrogen carbonate. So metal is sodium, but then we have to recognize hydrogen carbonate is a polyatomic ion. This one is a little tricky. You might not have even noticed it there on your list, but there it is. It's on your list, and they both have charges of 1, so you don't see any subscripts for numbers here. Next, we've got Stanic Bromide. Stanic is one of those special Latin names for tin. So this is dealing with tin, and it's saying IC ending here, which means I need to use the larger of the 2 charges for tin. Tin can be 2 or 4, but since it's IC, I need a charge of 4, which crisscross down here. And bromide is for bromine, which has a charge of 1, which goes right in here. We don't see it because we don't put the number 1 in, but it's there. Next, manganese to silicate. So here we've got Roman numeral 2. It's telling us which charge of manganese to use. And silicate is a polyatomic ion on your list, so you need to look up that ion. It's SiO3, and it has a charge of -2. So does the manganese. So both of those 2's cancel out, which is why you just see MnSiO3 here. Lastly, sulfur dioxide, SO2, 1 sulfur, 2 oxygens using the prefixes. So hopefully that little activity there gave you a bit of time to warm up and start thinking about what you would want to do for naming going forward. So this little exercise covered some ionic and some covalent and some polyatomic compounds. So now let's go on to the next part of our lesson, oxyradicals. So oxyradicals sound a little bit strange, but basically what they are a series of polyatomic ions that contain oxygen. Now you've seen a whole bunch of polyatomic ions from your list, and those ones are ones that are the most common, or your core list or your base list of ions. Sometimes what happens is the number of oxygens in those ions change, and when they change, their names change, and there's a pattern and naming rule for them. So all of the ones that are on your core list of ions, we call them base ions, those are the most common ones on your list. And I'll put a little star here. This means on your list. So what happens when the number of oxygen atoms changes? There's prefixes and suffixes that are used. So let's take a look at an example so you can see how this works. So we're going to find our most common form of our ion. Lots of them just end in ATE. So from our base list, it would be ATE. And here we're using an example with carbonate. So carbonate, CO3 with a -2 charge, that one is on your periodic table. Or sorry, that one's on your ion list, not your periodic table. So now what's going to happen, we're going to compare the number of oxygens we start off with for any ion that's on our list. And if we start removing oxygens, the name starts to change. So one less oxygen than the base ion, the ending is going to change to ITE. And when we look at the formula, this one had 3 down here. Now it's going to go to 2. Let's take a look at the next one. What if there's 2 less oxygen atoms than compared to your base ion down here? So if we take 2 away here, it wouldn't be CO3, it would just be CO. What you have to do there, the ending changes to ITE, but you also have to add on this prefix hypo. So this would be called the hyposulfite ion. This one's just, hypocarbonite ion. This one is called the carbonate ion, and this one's called carbonate. There's one more scenario you can run into. What if there's an additional oxygen compared to your base ion? So when we look here, this was 3, now it's going to 4. The ending here stays as ATE, but you're going to add on a different prefix, you're going to add on per. So this would be normally carbonate up here, and now this ion is called percarbonate. Now you might have also noticed something else. The charge here, no matter which one of these ions you have, doesn't change. So since this doesn't change, that makes it a little bit easier. If it's -2 to start off with, it's going to be -2 throughout. It's just the number of oxygens that change. So let's keep going and take a look at some other examples so you can get the idea of how this works. So we're going to just work our way through writing down some of the formulas of the most common ions from your base list, and then we're going to look at what happens when we start changing the number of oxygens that are there. So I just highlighted here, this is our base list, or our base ion, and most of them end in ATE on its own. So when I go down my list of polyatomic ions, I'm looking for one that has nitrogen and oxygen, and hopefully you see nitrate. Nitrate is NO3 with a -1 charge. So when I name this, this is the nitrate ion. NO3 with a -1 charge. Now, what if I have per-inate? What does that mean for the formula? This means plus 1 oxygen. So, NO, since this was 3, now this turns to 4. Charge doesn't change, so I put a negative charge there. And the name of the ion changes. Now I put per, then nitrate, and if it's just by itself, we add the word ion, but if it's combined in a compound, we don't need that word ion there. Now let's look over here. IT ending was for 1 less oxygen. -1 over here was for 1 less oxygen. So if I'm looking here at my NO3, it's going to be NO2. -1 charge is still there, but the ending changes. This changes to nitrite, and on its own we call it nitrite ion, so we put that word in there. But if it's combined with something else, again, you don't need the ion name because it's not an ion anymore. Then the last one, hypo and ite, is when you lose 2 oxygens. So NO, we're losing 2 from here, remember? So going from 3 to 2, now to 1. We don't put a 1 in there, but we keep the charge. So this is called Hypo Nitrite Ion. So hopefully you can see a little bit more how this works with different ions. When you adjust the number of oxygens from that list that you have, it either increases or decreases, and you either add on prefix and suffix, or just a suffix, or just a prefix. So at this point, what I'd like you to do is try and do the same thing, but find a polyatomic ion with chlorine and find a polyatomic ion with carbon, and see if you can fill in the next part of this table. So pause the video at this point and see if you can fill in the other parts. When you're ready, unpause, and we'll take a look at the answers. All right, so let's take a look and see how you did. So here we go. We've got the chlorate ion. This one here is your base ion from your polyatomic ion list. We've got perchlorate ion over here, 1 extra oxygen. When we lose 1, it's called chlorite ion. And the last one over here is the hypochlorite ion. It's lost 2. So it went from 3 to 2 to 1. Charge is the same all the way across. Now let's look at one with carbon. So one with carbon is your carbonate ion. Here's your base ion from your list. 1 extra is called percarbonate ion. 1 less is carbonate. 2 less, hypocarbonate. Just to make sure you're on the right track, let's try a couple more before we look at some other examples. So 2 more for you to do. Try and find a polyatomic ion on your list with sulfur and oxygen, and find one with phosphorus and oxygen, and see if you can fill in this table. So again, pause the video, see if you can fill it in, and when we're all ready, we'll unpause the video and you can check. All right, we're back. So hopefully you tried these ones out. Let's take a look. So when we look on our list here, the sulfate ion is the most common one, our base list. So it starts off as SO4 with a -2 charge. What happens if there's an extra oxygen? It's SO5. -2 charge is still there. We call that the persulfate ion. What if we go the opposite way? 1 less, so instead of 4, there's 3. Sulfite ion. 2 less, hyposulfite ion. Lastly, we've got our examples here with phosphorus. So PO4 with a 3 negative charge is the phosphate ion. One extra, PO5 negative 3. So we call that perphosphate ion. What if we lose one, PO3 with a negative 3 charge? Then it's phosphite. PO2 with a negative 2 charge, we've lost 2 oxygens, so hypo and ITE are on there. So now that we've practiced how some of the ions change, what we'll do is try out some examples. The few that we went through here, that's not a complete list. These rules could be applied to any of those ions on your big long polyatomic ion list that have oxygens in them that end in ATE. So watch out, because this is where it's going to get a little bit tricky. You need to look on your list and find an ion that's similar, and then we're going to try and apply those rules. So let's take a look at a couple of examples together. I'll do one with you, then I'll let you try the others, and then we'll take them up. So first thing I do, just like I do often with my polyatomic ions, it's often very helpful. Highlight the first element or circle it, and then you can see what the polyatomic ion might look like. So this first element is a metal, and we know it's calcium. And before I do anything else, I'm going to check, does calcium have one charge or is it multi-charge element? And it only has one charge, so then I know I don't need my Roman numeral or classic ending for it. Then I'm going to go and look though, SO2. So I go to my polyatomic ion list, and I'm going to go down and look for something with sulfur and oxygen. On my polyatomic ion list, I'm going to find the sulfate ion, SO4 with a negative 2 charge. Here though, when I look, I only see 2. So when I compare it to my main list, I've lost 2 oxygens. So it was sulfate, but now it's going to change. So the name of the polyatomic ion, which I'm going to put next, has to be hypo sulfite. Because it's lost 2, going from 4 to 2, I put on hypo for my prefix and ITE for my suffix. So now why don't you give these 3 left a shot. So pause the video and see if you can name them, and then we'll check the last 3 off together. Okay, so when I go and look, I'm going to take up the answers now. My metal is aluminum, and it only has 1 charge, so I don't need to worry about Roman numerals or anything. Here I've got PO5. My root ion, when I look at my list, is PO4 with a negative 3 charge. So here, instead of PO4, I have PO5, 1 more. When I have 1 more, I need to add on per in front of the name. So this is aluminum per for phosphate. Next one. My metal here is magnesium. So I write magnesium in. It's also only having a single charge, so I don't need Roman numerals or ending change. Then I go and look on my list. I need to look for my base ion with chlorine and oxygen. My base ion is chlorate, ClO3 with a negative 1 charge. I can see that I've lost 1 oxygen here. So when I lose 1, the ending changes to ITE. So instead of chlorate, I have chlorite. So altogether, magnesium chloride. Last one, here we've got hydrogen as the first element, which is fine. So it starts things off. But again, here I've got a polyatomic ion with nitrogen and oxygen. So when I go on my list, I go down, and I should see that's the nitrate ion, NO3, with a negative 1 charge. Here it's lost 2 oxygens. So here again, when I lose 2, I need to add on hypo. And instead of nitrate, it's nitrite. So hopefully this helps introduce the idea of oxyradicals. So once you get comfortable with the idea of the naming rules, and you start to get more familiar with your polyatomic ions, it will get easier. But please make sure that you get lots of practice with this topic, because now it gets a little bit more confusing, because things are going to look a certain way. But without the naming rules, you'll have some trouble. You'll always have your polyatomic ion list, so always have that handy, but you need to remember those rules for the endings or the prefixes that go on and when to use them.